Over to you, Hoon.
That's great. Can you share, see the slides, Jeff?
Yes, we can.
Okay,
Yes.
great. Thank you for inviting Anzen Technology Systems this morning to speak to you guys and give a presentation, short presentation and a demonstration of our technology. Today, it's myself, Hoon Lee. I'm the CEO of Anzen, and I've got our CTO, Charlie, who's also online, who's going to go through the demo as well. So just in terms of agenda, just a bit about background, who we are, what the problems we're tackling, where we are at this point in time. And we're going to talk about a core patented part of the technology, which is a post-quantum security for cloud. And also talk a bit about as well how our recent projects in terms of developing tooling together with our core technology enables cloud strategy, including for the project that we've just delivered for the UK MOD. And we're going to give a demonstration of the core technology working with these toolings. And if we have time, I can go through various national security and industry example use cases that we can apply our core patented technology to. And I believe towards the end, we've got 10-minute Q&A. Right. So some years ago, we as consultants all recognized in data management, there was two really the biggest questions in data management, which is really security and privacy of information. And also this thing called data sovereignty, which to me means retaining control and showing you've got control of your data and your customers' data. And also as consultant, especially working in cross-border implementations as well, where there's massive proliferation of data, and it was really the start of also cloud computing as well, where the data could be anywhere. Obviously the regime at the time in terms of security and data sovereignty we felt was lacking. So we set ourselves a challenge to say, look, what if the security regimes are breached, bypassed, and even standard encryption broken? How else would you be able to protect that information and retain sovereignty? That's when we submitted it as a patent. Some years later, got awarded the patent, and then we formed the company Anzen Technology Systems to turn the patent into working software. And our mission, we were, originally from the cloud. We focus on the cloud, and what we fundamentally do is allow organization to leverage public cloud computing for highly sensitive or classified information, whilst at the same time future-proofing information security, which I'll go into in a minute what I mean by that, and retaining control and sovereignty of that data. So how does the solution work? At a very high level, if you can imagine an analogy where you've got a jigsaw puzzle with text information or pictorial information, what we do is we take in that jigsaw puzzle and we do two things to it. Firstly, we blank out all the identifiable information, all the text, all the pictorial information. And then secondly, we then split up into individual pieces, what we call data shards. Our system defaults to 4 data shards, but you can have as many data shards as you like. The key thing is about these individual anonymized data shards. There's no information on it whatsoever. The only way you can find out the original information is if you have all of those, say, 4 shards and know how to put it back together again. In terms of this technology, what we've sort of labeled as ASR, anonymized shard and restore, and what you do get is actually all the good bits on the bottom right hand side, where you're lowering attack concentration, lowering aggregation risk compared to a centralized store, and also massively reduce inclusion, where you can have individual data shards, for instance, not with just one cloud platform. You can have it up to, say, 4 other cloud platforms. And also for the people interested in the Cloud Act, it also mitigates against the risk of the Cloud Act as well. We originally had an MVP, was talent spotted by the MOD. They gave us a project and we then matured it into production technology, which we're going to show as part of our demonstration later. And when I say these individual data shards are there's no information whatsoever, we've also got a maths proof from one of your peers Professor Akin Brooker, who carried out mathematical proof and apply formal methods to basically say these data shards are unreadable, and it provides this thing called perfect secrecy, which in layman terms means it's immune to all brute force attacks, including from quantum computers. So what you're effectively doing using our technology to protect your information is you're future-proofing that information today against steal now, decrypt later risk. Originally, we got our technology to work for structured and unstructured information. We applied it for data arrests, data storage, data archives, data backups. And then actually, a couple of years ago, we then thought, why don't we try and use an anonymized shard and restore technique for real-time data? And we actually got that to work as well, so which is really super exciting. But today, we're going to focus on the commercially available, what we call ANS and Store, which is our technology applied for data at rest. The key thing about the technology that we've got, it's and the patent that we've got, the patent's already embedded, it's proven, it's not just on a piece of paper, so it's embedded in our latest version of the software. As part of what we do as well, what we want to do, focusing on the cloud, is it enables strategy. So if you take, for example, a cloud strategy of organization here, I've got the UK MOD, you've got policies and strategies all over. I've got just some of them listed here on the left-hand side. What we do with our technology, we enable the cloud strategy, we believe. So for instance, the core technology that we have, the patent technology, the ANS and security, the ASR, it provides security benefits in terms of post-quantum cloud protection and data sovereignty control, even if that classified or sensitive information is sitting in the public cloud, Azure, AWS, Oracle Cloud, etc. What we've also done as our company matures and our product roadmap matures as well, we've developed self-service tools which enables a lot of operational benefits here. As you can see on the left, on the right-hand side, what we've developed these tools to be self-service without having, expensive DevOps. You can do it yourself, or get or have central IT do it very, very, very quickly. So we massively reduce implementation time, reduce IT burden. We have connectors that connect directly to front-end applications as well. So we remove bespoke systems integration. And ultimately, it's a very agile response to the front office. In this instance here, the front office being frontline ops, frontline command and ops for the MOD. So if you got compare and contrast to what we have today to what you could have with ANS, is on the left-hand side, you've got typically, this is the topology of cloud storage. On the right-hand side, what you've got is you've got all the benefits as described in terms of reducing the respective risk using the technology for ANSEN. So we're going to go straight in, or go into the demonstration where Charlie's going to show you facets of different parts, not all of the technology, but the core part in terms of data anonymization, sharding, and restore, together with some of the tools that we developed in our latest project for the MOD, and also application connectors where we can connect to compatible front-end applications. So I'm going to hand over to Charlie to give the demonstration. Charlie, before I stop sharing, can you just describe in just a minute in terms of what you're gonna do in your demonstration?
Yeah, no problem at all. So the demonstration I'm going to show you is broken into three fundamental parts. The first stage of this is install. So this is as a DevOps engineer would do. In this case, we're starting from a Kubernetes cluster, just for time's sake. We're then going to install an instance of ANSEN within that Kubernetes cluster from scratch using a Helm chart, and then we're going to show and talk about some of the services that we've installed. The next stage is configure. We're going to go into our administration dashboard. We're going to set up a connection to an external cloud account, some locations, some buckets, and some access provision. And then the third stage is use. So this is going to be an example of an end user or a connected system. But in this case, we're going to use a graphical user interface tool for S3, just as an example of some kind of S3 compatible client. We're going to push a file up, we're going to pull a file down. We're then going to show you in our telemetry platform called Uptrace, and we're going to show you how that file progressed through the system, all of the inbuilt metrics and tracing functionality that we have to allow for good observability. And yeah,
that's brilliant, Charlie. I'll stop sharing now, and then you can share your many screens you've probably got open. Yeah,
this is where we hope it works. Can you guys see that okay?
Yes, I can see your screen, Charlie.
Good. So we're going to kick off this with the install. We're going to show that this is just an empty Kubernetes namespace. There's nothing in here. We're going to quickly run an install of a Helm script. And this is going to install all of the various services. It's going to install Ingress. It's going to configure the networking. It's going to configure all the security policies, everything from scratch. So all this needs is an empty Kubernetes cluster. And then this will build on top of that. We also provide scripts for provisioning the Kubernetes cluster. I'm just going to quickly bring up some of the pods here. So in this case, we've installed a few different instances of different things. We've got some of the API server at the front side. We've got some of our internal services like processing and object and bucket, the things that are responsible for those elements. And then we've got the storage service at the back end, which is what's actually persisting the data out to the chosen cloud providers. All of these are auto-scalable. They can all change dynamically based on demand. This is just the base level of scaling that we've set up. So any of these can scale up or down independently of the rest of the components of the system, and they will all handle that transparently. So I'll just shift now to the second stage, which is configure. In this, can you see this dashboard okay? This is the Anzen configuration dashboard. As you can see here, we've got this nice little globe on the right-hand side, which shows the locations that we have pre-configured. And we'll go through how to get how a normal administrator would go through the process of configuring the Anzen system. So the first thing is on the left-hand side here is the cloud accounts. So in this case, we have configured an AWS cloud account connection. So this is a set of AWS credentials to allow it to connect outbound in order to store shards. And as you can see, we've also selected the Europe region here. So within that region, we have 4 buckets created. You can see those buckets on the map here, and you can also see that we have the actual instance itself in Germany over here. And you can see the connections between them. The next thing we're going to skip to is locations. So this is an individual location. This is a location at which a shard of Anzen secured data will sit. So in this case, we've got one here in the UK, in region EUS2, and we've also got created here a location configuration. So in this case, this is a set of locations which will be used to store the data contained within a bucket, and a bucket is then linked to this location configuration. And we're going to hop into the bucket view. We've created a bucket here called Anzen. This is just a simple bucket that's pointing to this configuration. This will be exposed as an S3 compatible bucket from our S3 API. In here, you can see some attributes about the bucket. Obviously, you can turn on a few of the settings for buckets. The next thing I'm going to show you is the access panel. So this is users and permissions. I'm going to quickly jump into this user here, which is me. As you can see, all of my details are in here. You can also see in here, we've set up some S3 credentials, which we're going to use in a second to connect with an S3 compatible client to the Anzen S3 API. So I'm going to jump to the next stage of the demo, which is the use phase. As you can see here, we've got a few different windows open. At the top right, we have a tool called CyberDuck, which is an S3 compatible graphical user interface. On the bottom right, we have a little folder that's got a test file that we're going to use in a second. And on the left-hand side, we have a tool called Uptrace. This is an observability tool, so it allows you to view metrics, tracing, logs, all together and all linked together so that we can jump around and nicely view all those different attributes. So the first thing we'll do here is we're going to connect to our S3 bucket. We're going to bring this file, this MP4 file down here.
Charlie, just
Yep.
sorry, quick interruption. For some reason, the left-hand part of your screen is pretty blurred.
Oh, one sec. I think Mac OS might be trying to be clever. Is that sorted itself out?
Clearer now, Charlie.
No, that's clear now.
Okay, that's portrait mode in Mac OS trying to make it look pretty. Right, so I'm now just going to grab the this test file that we have down here, and I'm going to go drop it into Cyberduck. And that's going to push it up to through our API to the S3 bucket we created earlier. And I can now just drag that back down into here. We're going to drop it into that folder and download it. So you can see we've downloaded a new instance of that file. We can go ahead and open that file. And we can play it. Obviously, just show that it's the same video, obviously. That's the original file that we had. I can now go into our metrics and observability dashboard here on the left, and we can see all of the different events that are fired here. You can see the little uptick in traffic that was me before. We can go in and select this individual service, which in this case is the S3 API service, which is the top level. And actually, we can go into tracing, and we can do this. Sort by time. So, and we can see all the various requests that were made here. In this case, you can see a GET request. If we go into this, we can see all the log events that were fired during this request. So there's linking between all of the different elements of this, the metrics, the logging, and the tracing. You can see here that we got, that's the file that we pulled down. You can see all of the different attributes, request, user agent, IP address, all of the various parameters. We can go in here and hit view trace. This will allow us to view all of the tracing information for this entire request, all the microservices that responded, all of the timings for them, all the database queries that were run, and also all of the attributes within all of those operations as well. So you can see here, this is where we pulled down the individual shards from the various AWS regions that we'd stored them into, and then we performed the ASR restore process on them. We then removed the traditional encryption that we laid on top, and then we decompressed it, and then we wrote it back out to the client who made the request. So yeah, that concludes the demo. Thank you very much for your time.
That's brilliant, Charlie. I've just got a few more slides to go through, some bit more information. If I just share as well. So Charlie, literally in minutes, which, you know, if you got a DevOps, you know, 100K a year DevOps person, it would take a lot longer than what Charlie's done there in terms of the tooling that Charlie's leveraging, that we've developed. So literally within minutes, he was able to install an instance of it, be able to get up and running, configure that a few more minutes, and then start using it. And the demo here using a Cyberduck as a connection, be able to show that he was able to take that MP file, that video file, and then anonymize shard it, and then eventually restore it from the cloud. So all these, as I said, you know, the core technology, the Anzen security, and our Anzen self-service tools enables cloud strategy, not necessarily just the MOD, it could be any organization where privacy and security and data sovereignty is paramount. Together as well, be able to install that, configure that, use that without having a massive reliance on central IT or very scarce and expensive DevOps resources. And so, you know, there's a lot to take in there in that short demo that we just put, that Charlie just gone through. So typically what we do with interested customers is basically just do a trial, a fixed term trial, where we go through and prove to them that they can achieve benefits using our security and our tools, the security benefits as well as the operational benefits. And in terms of the startup life, it's very up and down, as you can imagine, but the last couple of years has been pretty good. Like I said, we've got interest from the MOD. We've even got interest from the Singapore MOD and the various government entities there. We had very good news just a few weeks ago where we got awarded our second patent for our technology. And in a couple of weeks, not actually less than a couple of weeks. Myself and Charlie are going to be demonstrating part of what's shown today to a load of MOD stakeholders. And these are just the list of use cases that our technology could be applied to. It's not just applicable for uploading video files and then protecting it in the cloud. There's various different use cases where you can apply the anonymize, shard and restore technology. Some of these actually came up not from ourselves, but from industry experts who knew more about technology and said, can you apply it for this? Why can't you use it for that? So you can see a whole list of just examples for national security on the left-hand side, and also a whole list of different examples for industry on the right-hand side. And I think that's the end of our presentation.